Hello viewers, I am Kausalya. Today we are going to solve problem number 17. The problem is obtain the solution of the homogeneous state equation x dot equal to ax where a is given by this 2 by 2 matrix and x of 0 is given by this 2 by 1 matrix. Right. So here the solution is the homogeneous state equation is given by x of t is equal to e to the power at into x of 0. Again we know e to the power at is nothing but inverse Laplace of si minus a, the whole inverse. So si minus a we know, right? Yes, and here the identity matrix should be of the same order as the given matrix A. So here it is a 2 by 2 matrix minus A matrix is given in the problem. Just substitute it over here. So when you solve, here we are getting the answer as, again this is a simple multiplication, right? S gets multiplied with this matrix. Therefore 1 into S, yes, and 1 into S, yes. Right. Now we are going to subtract. So S minus 1, S, right? So this term, that is this row, gets multiplied by this column. So sorry, this is not a multiplication, this is a subtraction. So here S minus 1 here, and 0 minus of minus 2 becomes plus 2, and 0 minus 1 becomes minus 1, and S minus of minus 4 becomes S plus 4. Right. The next step is we are going to calculate Si minus A, the whole inverse. So this is given by the formula adjoint of Si minus A divided by mod of Si minus A. So adjoint of Si minus A is nothing but we have to interchange these two values. So when you interchange, it becomes S plus 4 into S minus 1, and here these two numbers, the sign should be changed. Here plus 2 becomes minus 2 and here minus 1 becomes plus 1. Right. And next one is determinant of Si minus A. So when you take the determinant as usual here, S minus 1 into S plus 4 minus of minus 1 into 2. Right. So once you multiply and simplify, here we are getting the expression as s square plus 3s minus 2. And when you factorize, we are getting the answer like this, right? You can just use a calculator to get these answers. Okay, no need to solve by yourself. And the next thing is Si minus A, the whole inverse, right? So we had calculated adjoint of Si minus A. We know the determinant of Si minus A also. So here when you substitute it in the place, you see S plus 4 here, this S plus, that is this entire matrix gets divided by this term, right? Now we are just simplifying the terms further. I am writing this denominator term for each and every term which is present in this matrix. So when you write here, so here the values are S plus 4 by S minus 0.561 into S plus 3.561. Similarly for this minus 2 and for this 1 and for this S minus 1. Right. Now we are going to solve for each and every term here. So just consider the first term. So here when you write, we will be having, since the denominator has two terms, here we will be having two elements. We are naming it as A1 and B1. So when you take LCM, right, the same thing. So when you take LCM, we will be having an expression like this. Then the next thing is we have to calculate the value of this A1 and B1, right? Here A1, B1. So to find the value of B1, right? Here we are substituting the value of S as minus 3.561. When S is minus 3.561, the value of A1 becomes 0, right? So just substitute the values accordingly. So when you substitute S is equal to minus 3.561, the value of A1 is 0. Therefore, it is easy for us to calculate the value of B1, right? So the value of B1 is minus 0.106. And again to calculate the value of A1, we have to substitute the value of S as 0.561. So that 0.561 minus 0.561 becomes 0, right? So likewise, just substitute the values and calculate the value of A1 and B1. Similarly, we have to calculate the values of the remaining terms. So totally this matrix has 4 elements, right? So when you solve the first element, we are getting A1, B1. Similarly, when you solve the second element, we are naming it as A2, B2. Third element, A3, B3. And for the last element, A4 and B4. Right. So here, this is our second element. Again, by partial fraction, we are splitting. Again, taking LCM. And we are arriving up with an expression like this. So here in this case, again when you substitute the value of S, right? So when S is equal to minus 3.561, what happens? This A term gets reduced to 0. So we can calculate the value of B. So again here it is A2, B2. Right. So solve accordingly and the value of B2 is 0.485. Right. And here the next thing is when you substitute the value of S as 0.561, right. So now the value of A2 is calculated as 0.485. So now we had calculated A2, B2. Similarly, when you consider your third expression, right. So here the terms are A3, B3. So as usual, by partial fraction, just split and write and just substitute the values, right, accordingly and calculate the values of A3 as well as B3 here. Right, here both the values are B3 is minus 0.2426 and A3 is 0.2426. Now we are proceeding to the fourth term, right. So here, this is our fourth term. So by partial fraction, here we are naming it as A4, B4. And again, as usual, you have to take LCM here. So once you take LCM and solve, we are ending the problem by having this values, right? B4 is 1.106 and A4 is minus 0.106, right? So now we are going to take inverse Laplace for the each and every answers we get, right? So here for this expression we are getting the answer as this. So when you take inverse Laplace, right, here we are having a constant, so write the constant as such, and here it is, that is S minus this term should be written as e power plus 0.561t, right, minus here 0.106 and again e to the power minus 3.561t. Right. When you consider the second term, so when you look at the second term here, again when you take inverse Laplace here, the same thing, minus 0.485 e to the power 0.561t and again 0.485 e to the power minus 3.561t. Right. Similarly, you just solve for the all the terms. So this is our third expression. So again when you solve, we are ending up with the expression like this. And finally, this is our last expression. And again when you take inverse Laplace, we are having an answer like this. Right. So after framing up the answers, now we are writing it in the form of the matrix. So when you write it in the form of matrix, so this is our e to the power at matrix. Right. So here this is our e to the power at matrix. So what we want actually, so this is the thing we want, right? So x of t is equal to e to the power at into x of 0. Here x of 0 is given in the problem and just now we had calculated the value of e to the power at, right? So when you proceed, here just substitute the values, that is e to the power at gets multiplied with x of 0. So this is your e to the power at which gets multiplied with, this is your x of 0. Right. So again the same way, you see, this is your first term and this is your second, this is your third and this is your fourth term. Right. Again when you multiply and when you simplify, right, we are having an expression like this. Right. So once you solve this equations, finally we are ending up with this x of t value. So here as usual, so this is a 2 by 2 matrix and this is a 2 by 1 matrix, right? And this 2 will cancel. So the final output matrix will be having 2 by 1, right? 2 rows and a 1 column. So you see, when you solve, we are having 2 rows and a 1 column. So when you simplify, you see here e to the power 0.561t and here also e to the power 0.561t. So when you solve these two terms, here we are having 0.553 and here we are having minus 0.48. So when you solve this, we are ending up with this type of expression, that is 0.068 e to the power 0.561t. And again, when you solve these two terms, our answer is 0.432 e to the power minus 3.561t. And again, when you simplify this expression, we are having answer like this, right? So this is our final answer. I hope everything will be clear to you. If you have any doubt, let me know in the comment section. Thank you.